Listen-only mode.
Hello and welcome to the OASIS ODATA Technical Committee webinar. My name is Dee Shore. Here's my email address. We have two speakers today. The first is Barbara Hartle from SAP and Michael Pizzo from Microsoft. We will also have a few other panelists joining us for our question and answer period. Just a couple quick reminders. As we go through, when you downloaded the software to start the webinar today, there was a box that popped up on the right side of your screen. If you would like to reduce or expand the control panel, just click on the orange arrow that's located on the tab. We will be taking questions throughout the webinar today. Feel free to type the question in the question box at any point during the webinar. We will review all the questions at the end. In an effort to make this more interactive, if you have a sort of complicated question and you would like to speak, I can give you control to speak. So just send me a little message in that question box stating that you would like to ask your question live. If you'd like to view other browsers during the webinar, just click on your view, which is an option on the top menu, and choose full view or Windows. Again, here's my email address. In a few days, this webinar will be downloadable from the OASIS website. Here is the link to all of our webinars. There are a lot of interesting webinars there. Again, I will send you this link in a follow-up email. And another few announcements. We are sponsoring the OASIS Open House and Cloud Standard Lightning Round event that will be held in Burlington, Mass., and you are all invited. It's open to members and non-members. Here is the link to that event, and I will also send this link in the follow-up email. And with that, I would like to turn it over to Barbara.
Hello everybody and welcome to the Open Data Protocol webinar also from my side. It's great to see that so many people are interested in OData and in joining the webinar. My name is Barbara Hartle, I'm from SAP and I'm currently the convener of the OData Technical Committee. I'm doing this session together with Michael Pizzo from Microsoft. Michael is the technical expert for OData and will actually do most of the session. So the agenda for today's meeting is that first I will start with some information about the OData Technical Committee, and after that Mike will give you an overview of OData. At the next point, Michael will also talk about the work of the Technical Committee, which is ahead for the committee members. At last, we will have some time for your questions. So the OData Technical Committee was announced May 24th this year. Supporters are Microsoft, IBM, SAP, Citrix, VSO2, Progress, CA and Red Hat. The initial contribution includes the contribution of the OData version 3 specifications for Microsoft and 4 extension documents. Michael will give you more details later. The call for participation was June 11th, and up to now 23 members have joined and 8 observers. The first meeting will be at 26th July and 27th July in Redmond. So please have in mind that members must join by July 19th to be voting members at the first meeting. The Charter proposes that the standardization will be done in about 12 months. If you plan to join the Technical Committee, or if you're interested in more information about the OData Technical Committee, you can go to the homepage at OASIS of the OData Technical Committee and just click the Join button there on the top. And now, Michael will continue with an overview of OData.
Thank you, Barbara, and welcome everybody this morning. Thank you for all being here. let me see what we need to do to switch over. Great. Okay, great. Again, my name is Mike Pizzo. I'm a software architect at Microsoft, and I've been working on OData for about the last 4 or 5 years. And this morning I kind of wanted to give a brief overview of OData just to make sure everybody was at the same base understanding of what OData was, and then talk specifically about some of the work that is going to be going on in the technical committee at OASIS in order to bring OData to a standard. So starting at a very high level, what is OData? OData is a web protocol for working with data. It supports querying data, updating data, and being a web protocol that relies only on an HTTP stack, it really opens up the data that has previously been locked in application silos. Now, the unique thing about OData, there's a lot of other HTTP RESTful interfaces. You can find a bunch of them on the programmable web. But the unique thing about OData is that it's designed to be a common, shared, open protocol. And the real power of OData is not in any one decision, design decision or implementation, but the fact that many people are implementing the same patterns, the same conventions, and the same functionality on top of a common protocol. Some of the principles that were designed and helped shape OData were basic REST principles born out of HTTP. OData is a resource-oriented interface, so OData deals with collections of things where those things are called entities and they're modeled as resources, and those entities are collected in entity sets, and the entity sets are modeled as collections. Relationships between different resources are modeled as links, so it's very hypermedia driven. And we use common HTTP verbs, post, get, put, patch, and delete for doing CRUD operations, the create, read, update, and delete operations against the resources. As I say, OData is very hypermedia driven, so you can start out from a URL that indicates the service. You can explore and get the metadata that describes that service. You can get the service document that allows you to see the collections that are available. And you can, from those collections, query the collections and navigate to related elements of members of that collection. The payload itself includes links that allow you to go from one state to another of an individual entity. So for instance, if you want to edit the entity, there's an entity link. If you want to refresh the entity, you can use an edit link or a self link. And if you want to navigate, there are navigation links. OData is very model based. In fact, unlike a SOAP interface, the contract for an OData service really is the data model. So once you understand the data model, as is described by the $metadata endpoint of an OData service, you really understand exactly what functionality you have in working with the service. You know the URL space, you know the namespaces, you know the entities that you're working with, their shapes, and so forth. And finally, OData is built on existing formats. We have an Atom format and a JSON format rather than defining new formats. And so we use the extensibility built into Atom and JSON in order to express through common conventions additional information that isn't defined in those base protocols. We'll dive a little bit more into the OData entity data model because it is pretty important for understanding OData. The OData model is an entity relational model as described by Peter Chen in his paper. So there are entities. Entities are name structures with keys. Entities support type inheritance. Entities have properties. The properties can be of standard primitive values of string, integer, bool, date, time. We also support spatial data types. Properties can be collections of primitive types, and they can be complex types, which are structures that do not have keys. We also support stream properties and the concept of dynamic or open properties. That is, an entity can be specified that it can contain properties not described in metadata that are described on the wire. And then entities have relationships. Relationships are exposed navigation paths that allow you to go, for instance, from a customer to a set of orders for that customer. ODATA defines common semantics on top of this RESTful protocol. The semantics include support for query, so there's basic filter, sort, projection functionality. There's built-in functions for strings, booleans, and math functions. The ODATA query semantics support client-side paging, so the client can ask for just a range of records within a set of results. And servers can chunk results, for instance, returning only 500 records at a time. And we use common Atom Pub next link for navigating through multiple results. And finally, there's the ability for a client to express a request to expand results, so that in the request for customers, they can request that they also get the orders for the customers, for example. ODATA semantics also define semantics around navigation. And again, this is a very hypermedia-driven model where if you don't request the orders for a customer, the customer will come down with a link that allows you to retrieve the orders for that specific customer. ODATA defines data modification semantics, again, through post, put, patch, and delete. Post for posting to really any URL that represents a collection. So if you want to insert a new customer, you can insert that into the customer collection. If you want to add a new order to a customer, you have the option either of adding that to the orders collection at the top level, or adding it to the orders relationship link for the particular customer that you're associating with that order. So really any URL that represents a collection is something that you can post to. You can use put and patch in order to update an existing entity that you've retrieved using the edit link that was retrieved with that entity. Sorry, I have windows popping up. Put basically replaces the entity with the values that you specified. A patch updates just those values that have been specified. And you can delete an existing entity by submitting a delete to the edit URL that was retrieved with that entity. So again, it's very hypermedia driven. It uses the standard HTTP verbs. It just is conventions around that. Finally, ODATA defines batch operations, which allow you to, in a single HTTP request, make multiple ODATA requests, either for retrieving data or for updating data. And there's a concept of a change set, which allows you within a batch request to group a number of update operations that are then executed atomically. Actually, let me switch to here. ODATA has built-in extensibility. The extensibility comes in the form of several different facets. The first is the ability to define custom actions. Custom actions allow you to define side-effecting operations that essentially allow you to extend the functionality of the service. For instance, you could define an operation for inserting a new employee or adding a new employee, which would do more than just add the employee, but would also execute additional business logic. You could add a custom action for formatting a drive. And again, actions are very hypermedia driven, and so you can expose the actions as links on the entities that are retrieved. So for instance, you could retrieve an entity representing a drive and then call the format action on that retrieved entity using the link returned with that entity. Custom functions allow you to essentially extend the query language of OData through defining custom functions. Custom functions can be composed within a URL and used in, for instance, a filter statement. OData also allows you to extend the metadata of a service through metadata annotations, which allow you to provide additional information for the entities that are described as part of your service. So, for instance, you might have an annotation that says this string represents a URL. And finally, OData supports instance annotations, which are the ability to add additional information to the actual payload returned by the service. Extensions are interesting when they are between two cooperating ends of an end-to-end scenario, the service and the client, but they're more interesting when they're shared across multiple clients and multiple services. The idea of vocabularies is that you can share annotation terms. You can publish a common definition of what a term means, and then that term can be applied to multiple services and understood by multiple clients.
Mike, excuse me. Can you advance? Mike, can you advance your slides?
I'm sorry.
That's okay.
I can.
We're all seeing OData semantics.
Okay, so I'm sorry, my slides got behind. This is the slide describing extensibility, and the extensibility points, custom actions, custom functions, metadata annotations, and instance annotations, which allow you to extend the operations that are supported by OData, the query language of a particular OData service, the metadata that describes the entities in the service, and then the actual payload return in instance annotations. Okay, now we're back in sync. As I was saying, where annotations are used in order to coordinate information between a particular client and particular service, they're much more valuable when they're shared. And vocabularies are basically the concept of shared annotation terms, which allow you to define and share a definition for a term. So vocabularies are basically a set of annotation terms grouped together in a single schema, in a single namespace. And those can be published and shared and used across multiple services and across multiple clients. And so you can have common vocabularies for things like capabilities or display that allow you to extend the information that you use in order to describe a service or describe the results of a service. Vocabularies can also be used for ontologies, which are basically the ability to define common schemas across multiple services. So for instance, you could define a vocabulary for movies, and then whether you're talking to a OData service exposed by Netflix or by IMDb or by any other site that is exposing movie information, regardless of the schema that they've chosen to expose that information, if you apply this particular vocabulary, you can understand that a movie is a movie regardless of whether a particular site calls it a creative work or another site calls it a film or a title. You can have a common understanding of those schemas using vocabularies. Vocabularies can be included or can be applied to data and also to operations. So all of those extensibility points that we talked about, actions, functions, Annotations within the metadata and annotations within instance data can be shared through common definitions. So that's sort of a very, very, very quick overview of what OData is today and what the OData specifications submitted to the OASIS Technical Committee contain. So what then is the work of the Technical Committee? Well, the first piece of work of the Technical Committee is to take those submitted documents and turn them into a standard. So it's to address issues or comments, it's to address any errors or errata in the submitted documents, and to turn those into an actual final specification. In addition to the work that I just went over, there's been several different areas of work that have been of interest to the OData community for some time that we've explored within the OData community but are not yet part of the submitted document in OASIS. They are part of the OASIS Technical Committee Charter, and they are work that will be going on in the Technical Committee. So I wanted to describe those pieces of work very, very quickly. The first is the concept of deltas. In general, when you request data from an OData service, you'll get back all of the data that matches your particular request. OData is a great interface for retrieving reasonable sized amounts of data. But if there is a lot of data and you're trying to maintain a local copy of that data, you really don't want to have to retrieve all of the data at the same time. You'd like to just retrieve the data that is changed. So for instance, there's an OData service over Netflix, odata.netflix.com, and it has at last count something like 169,000 titles. If you wanted a local copy of that data, you would have to download initially 169,000 titles, which with server-driven paging in OData, you could actually do based on some server-specified maximum number per request. You could page through those requests 500 at a time and eventually download all 169,000 titles. But it would be sort of time-consuming and resource-consuming. Now, the OData service for Netflix does change over time. There's a dozen or so titles added every week. So every week you might want to get those dozen or so new titles, but you wouldn't want to have to download all 169,000 titles. So the Delta feature in OData allows a server to, along with the data, return a Delta link, and that Delta link can be used in order to retrieve just the changes to the data that have occurred since the data was initially fetched. And again, it's very hypermedia driven. The server is in control of specifying what that link is and can encode whatever information it wants. It's completely opaque from the client side. So that, in a nutshell, is a Delta feature. Another area that we've gotten a lot of requests is in the area of analytic data, and specifically the ability to describe analytic data and to submit aggregations requests over aggregated data. So analytic data, think of as BI cube, and the ability to describe aspects of that cube. For instance, you may want to describe that certain properties are measures, certain properties represent hierarchies or dimensions. You may want to describe certain key performance indicators within the data. Once you've described that information, you'll want to be able to express aggregates against that. So you'll want to query data representing sales over the past 10 years and aggregate it according to the salesperson. And so the analytic extensions, the aggregation extensions, introduce a dollar aggregate query operator that allows you to specify that you want to aggregate certain fields. And then it also adds a dollar rollup operator that allows you to express things like, I want to roll up the sales over the last 10 years by year. The third area of extension is temporal data, and temporal is something that's been added to SQL a number of years ago and allows you to query and represent data as of a particular time. So the common things that you'd want to do in representing and querying temporal data is, number one, to specify within your data the common fields that represent the from and to validity times according either to a system maintained time or an application maintained time. And so, as you might imagine, vocabularies give us a way to annotate the fields of an entity to say this field represents the from system maintained time, or this field represents the to system maintained time of a temporal range. Additionally, once you've established temporal data and represented the temporal data, you may want to query the data as of a particular time or as of a particular time range. So that involves defining temporal functions that can be used when querying those results. Finally, in many cases, the data that is represented by a particular column of an entity within the entity model exposed by the ODATA service might be a stream, and that stream might represent either structured data such as XML or JSON. And where that stream represents structured data, you may, number one, want to understand the content type of that structured data, that it's XML or that it's JSON. And additionally, you might want to invoke certain operations on that stream of data. So for instance, you might want to execute an xquery operation against a streamed property that represents XML. And so there's work going on proposed in order to add annotations and operations for representing, identifying, and operating on XML and JSON stream data. The final area of the technical committee is for those of you who have in the past been following on ODATA.org, will be familiar with the effort in order to define a simplified JSON format. The JSON format in ODATA today is JSON. It parses with JSON parsers. It uses objects, but it has specially defined fields for representing things like metadata and links and URI that are not part of the JSON specification. The additional information when you look at a JSON payload oftentimes leads people to get confused between which properties of the JSON payload represent metadata and which properties in the JSON payload represent the actual interesting data. So the simplified JSON format, or what we've been calling JSON Lite, takes advantage of annotations in order to have a common way to expose metadata versus the data, and additionally uses a templating mechanism in order to templatize out common metadata information. So for instance, the URIs representing relationship links or representing the self or edit link are often able to be computed based on information that is in the payload. So rather than including that information in the payload, which just ends up loading the payload by oftentimes more than the data itself, a templating mechanism allows the service to describe how to construct those URLs such that with the data in the payload, client library could construct the URL rather than having to transmit it over the wire. Again, it's very hypermedia driven in that all the information is there, the service is under control of how the URLs are constructed. It just gives a way for the information optionally not to be supplied on the wire with every request and every entry within the request. And there is an option within the simplified JSON format to expand all that metadata so that you do see all of the information in line. So there's a set of important core design principles that we apply in OData, in defining OData, that also need to be continued because they really form the core of what has made OData what it is. And the first principle is to keep things simple. And so in initially defining OData, we did not take everything that could be done in SQL and try to push it into the query language. Instead, we looked at the scenarios in which OData was particularly powerful, and we defined the subset of operations that hit the sweet spot of functionality while keeping things simple.
Excuse me, Mike, can you advance the slide?
Sorry, it advanced on my screen. I'm not sure. Oh. Just 1 second.
Okay. Perfect. We're with you.
Okay, great. Thanks. I'm not sure why this is lagging behind. So in addition to making sure that we don't try to boil the ocean in supporting everything possible within OData, there's also an underlying concept that the service wants to expose to the client the view that is most useful to the client. So rather than expose very raw data like in SQL where you'd expose the raw underlying tables and the client would create joins to relate interesting information between the different tables, by exposing an entity relationship model, the client sees natural navigations and is able to navigate those navigations rather than having to build the joins themselves. When we look at the extensions for aggregation in support of analytics, we try to apply the same principles. So what we try to present to the client is the aggregated view rather than force the complexity of a full MDX query language on top of the client in querying more of a raw set of analytic tables. As we said at the beginning, OData is hypermedia driven, and in the work that we do to continue to bring OData to the standards and to define these extensions around OData, it's paramount that we maintain that we continue to follow REST principles wherever possible, and that the model really defines the semantics of the service that you're working with. As we define extensions, we want to make sure that those extensions are incremental. Those extensions should not violate the core semantics of OData. Ideally, client libraries that know how to deal with an OData service should know how to deal with that OData service even in the midst of these extensions. So an existing OData client would be able to consume a service that exposed analytic data or temporal data and have reasonable behavior in working with that service. The client libraries and the clients that do understand those extensions can certainly have a richer experience, but the annotations and extensions should be optional for the semantics and behavior of the service. So for instance, when we're looking at the extensions for analytics and are adding additional annotations that describe things like hierarchy or key performance indicators, a client doesn't need to understand that information in order to represent the data and paint it on the screen. The one that does might organize the data a little bit better, might break it into hierarchies rather than flattening it into tables. Finally, there's this concept of being consistent, because being consistent and reusing common concepts across different extensions and core actually ends up greatly enhancing the simplicity of it all. And again, it all comes back to being simple. We want to make sure that OData services the scenarios that it's designed for, but doesn't get so bogged down that nobody can use it. And really the power of OData is in its simplicity, in that it's merely trying to define common semantics and common conventions around the type of RESTful HTTP interfaces that people are defining in custom ways against their data sources today. So with that introduction and description of the work in the TC, the thing that we would love is for more people to get involved and help us take this ODATA specification into a standard within the OASIS Technical Committee. There's more information on the OASIS Technical Committee at oasisopen.org, committees ODATA. There's a link there for joining the ODATA Technical Committee. There is an OASIS ODATA mailing list that you can submit comments to. So the OASIS Technical Committee will be sending out information about the work that's going on in the committee. You can comment on that work using the link shown in the slide, which I won't try to read. But you can use that in order to submit comments. That link is open to the public, so anyone can submit comments on the ODATA specification. And finally, you can participate in the ODATA community. And so we've had www.odata.org as a community that has been contributing to the design and information of ODATA for several years. We will continue to have odata.org, and we will be using that in order to solicit input, and in particular to coordinate around the community of ODATA, the different implementers that are implementing clients and services and libraries around ODATA. And with that, I think we'll open the floor for some questions.
Very nice, Michael. That was great. Thanks, Mike and Barbara. I had a couple different people ask during the session about the link to the reference, Mike, that you made early on about a paper by Peter Chen.
Yes.
So if you can send me that link, I'll push it out to all the attendees.
I will absolutely do that.
Okay. The next question we have, are there plans to register one or more media type identifiers with IANA?
That's a great question. We've actually been talking about, particularly for the OData extensions to Atom and JSON, representing more specific content types. And I think it would make sense to do that.
Anybody else want to jump in here and talk about that? No? Okay, great. I did get some very specific questions about membership, and I will be, for those folks that have sent those questions, I will be contacting you individually after the webinar. Okay. And I actually got several thank yous. Very good presentation. That's always terrific to hear. Thanks,
Great.
guys. That's excellent. Okay, so I think that's pretty much it. You covered the ground really well. Anything else to add in parting? We would be more than happy to have anyone join this effort. We're really excited about it. We do have the invitation to the open house at OASIS. That's another opportunity to come and talk to members and staff about this particular work or other ongoing and new efforts at OASIS. And thank you very much. Thanks, everybody. I appreciate it. Thanks, Barbara. Thanks, Michael.
Thank you. This has been great. I'm very excited that OData is taking this step to standardization. I didn't have my email in the slides, but if anyone would like to contact me directly, my email is mikep@microsoft.com. And in addition to sharing the webcast, Dee, will there be an opportunity to share the actual slides?
Absolutely.
Okay.
Absolutely. I'm sorry, go
Particularly
ahead.
since they got out of sync a couple times, I want to make sure that those are available.
Absolutely. That's fine. I will post them both in the same place. And again, I will have all those links in the follow-up email.
Great.
Okay. Thank you.
Thank you.